Okay, let's take a look at part 2 of U-Substitution, but this will be indefinite integrals using the trig functions. Now before we get started on this, let's just a reminder of the trig functions. On the left-hand side are the derivative of the trig functions. On the right-hand side are the antiderivatives of the trig functions. So keep those in mind before we get started because you'll need both of them on these types of problems. So first of all, let's look at a problem where you do not have to use U-substitution. The question sometimes comes up, how do you know whether you need to use it or not? So let's look at this problem. If you have this, the antiderivative of the cosine of x, as long as it's just a simple x, you do not need to use U-substitution. So go back to your definitions. Here, the antiderivative of the cosine of x is the sine of x plus c. So in this problem, you do not need to use U-substitution. It would just turn into the antiderivative of the cosine of x is the sine of x plus c, and you're done. So again, as long as it's simple x, you do not need to use U-substitution. Now, let's take a look at this. Exactly the same problem, but rather than having the cosine of a simple x, suppose you had this. The cosine of 3x. Well, now what you've got is a composite function. You've got the function 3x inside the cosine function. So in this problem, you are going to have to use U-substitution. So the way you'll attack this problem will be the following. It depends on the problem. Sometimes you let u be the argument of the trig function. Sometimes you let u be the trig function itself. In this case, we'll let u be equal to the argument of the trig function. So it's going to be this right here is what I'm going to pick for u. Now, if you haven't watched part 1 yet, I would definitely watch part 1 of U-Substitution because it describes this little box thing. And what I'll do is, just like in those previous problems, I'm going to change it from a problem in terms of x to a problem in terms of u. So I've got to get rid of this dx right here. I'll put the box around that. Now, exactly like you did in the things in part 1, start by letting u be equal to 3x. Then find the derivative. The derivative of u with respect to x would be equal to 3, which means that the differential of u would be equal to 3 times the differential of x. Now look back over here. You're trying to get a dx all by itself. You've got a 3 here, so you need to move that 3. So what I'll do is take the 3 from this side and move it to the denominator on this side, or just divide both sides by 3. So that gets me to 1/3 du is equal to dx. Well, now I'll put a little box around this. This part right here exactly agrees with this part up here, so I can trade out for this. Now this is exactly what we did in U-Substitution part 1. So again, if you need to, go back and review that before we go on this. And also go ahead and put a little box around this. I like to put all the U-sub part in its own little container. So we'll go to here and stick this in its own little box. So here is the U-substitution right here. Now, what that will get me is this. This will change it into the integral of the cosine, and now it'll become u, and I replace dx with what it's equal to, which would be 1/3 du. So I've changed the whole problem from an x problem into a u problem, but now I've just got the cosine of a simple u. Well, again, like we've done in the previous problems, go ahead and take the constant and move it out in front. So that'll give you 1/3 of the integral of the cosine of u du, which will give you 1/3, and find the antiderivative of this. Now go back to your trig list, and what you've got is this. The antiderivative of the cosine is the sine plus c. So this will turn into the sine of u plus c. And you're almost finished. We'll write this as 1/3 of the sine. Now remember, the final step is to replace u with what it's equal to. So u is equal to 3x, so this will change back into 3x plus c, and you are finished. So there's a simple example to begin with. So again, if it's anything other than a simple u, you've got to use U-substitution on it. Okay, let's take a look at another example. Now, in this problem, again, I'm going to pick my u so that its derivative gets rid of the other thing. So what I'll pick in this case, I'll let, my choices, I can either let u be equal to this right here, or this right here. Now, if I let u be equal to x squared, it'd be a poor choice because the derivative of x squared gets me to an x, but the derivative of x cubed gets me to x squared, so my choice of u is going to be this right here. So like we've done in the previous problems, I'm going to rewrite this. Once I make my selection of u, I'll put that on the left-hand side. So this will be the sine of x cubed. Then I'm going to take this x squared and move it over here. So that'll become x squared dx. And I'll put a little box around this. Now my choice of u is the x cubed. So there is u. Okay, now just like you've done in the previous problems, go ahead and we'll find the derivative of that. So u is equal to x cubed. Therefore, the derivative of u with respect to x is 3x squared, which means that the differential of u would be equal to 3x squared dx. Now again, look back up at your box. You need an x squared dx, but you've got a 3x squared dx. So again, I'll take this and move it to the denominator over here. So divide both sides by 3, which gets me to 1/3 du would be equal to x squared dx. Now at this point, I needed an x squared dx, and I've got an x squared dx. So you just play around with it until you manipulate it to the same thing. Now that will be equal to 1/3 du. And again, I'll stick a little box around this just to isolate it from the rest of the problem. So this was my U-substitution right here. So there is the U-substitution. Now when I plug that back in, here's what I'll get. This will turn into the integral of the sine of u, and I'll replace x squared dx with 1/3 du. Okay, again, bring the 1/3 out in front, which will get me to 1/3 the integral of the sine of u du. Okay, now just a reminder, to find the integral of the sine, let's go back and look at the table of values. So the integral of the sine is the negative of the cosine plus c. So this will turn into 1/3, and the antiderivative of the sine is the negative of the cosine of u plus c. And you're almost finished. Your last step now is to replace u with what it's equal to. So I'll move this negative out in front, and I'll have negative 1/3 of the cosine. And in place of u, I'm going to put what it's equal to right up here. So u is equal to x cubed. So this will be x cubed plus c, and I am done. So on this problem, you let u be equal to the argument of the trig function. Now sometimes you'll let u be equal to the trig function itself, and let's look at the difference in these. So sometimes you'll let it be equal to the argument of the trig function, and you'll see in the next problem, sometimes you'll let it be equal to the trig function itself. So let's take a look at that problem. Now in a problem like this, what I've got, if I let u be equal to 3x, the trouble is it does not get rid of the cosine of 3x. So letting u be equal to the argument of the trig function would be a poor choice. But if I rewrite the problem like this, I'm going to rewrite it as, just something I've always done. Rather than having it the sine squared of 3x, I'm going to write it like this. I'm going to write it as the sine of 3x, the entire thing squared. So take the 2 from here and move it to the outside here. So it's the entire thing squared. Then times the cosine of 3x dx. Now in this case, my choice of u is going to be the following. I'm not going to let u be equal to the argument of the trig function, but I'll let it be the entire trig function itself. Again, why would I do that? Because the derivative of the sine will get me to the cosine. But going back the other way, the derivative of the cosine will not get me to the sine squared. So pick your u, so the choice of u, when you take its derivative, gets rid of the other thing. So now that I've made my choice of u, I'll put a box this time around this. So this is what I'm going to try to get rid of. Now you still follow the same procedure. Let u be equal to the sine of 3x. So find the derivative of that. But remember, this is a composite function, so it's going to take the chain rule. So the derivative of u with respect to x, and again, if you need to, go back to your definitions. So the derivative of the sine is the cosine of x. So the derivative of the sine is the cosine, and then remember this is a chain rule. So take the derivative of the outer part, rewrite the inner part, and here's an easy little mistake to make, so I think I'll do it in blue where it kind of stands out. Then it's times the derivative of what's on the inside, which would be a 3. So the derivative of the outer part times the derivative of the inner part. Now for the next step, I'm going to go ahead and take this 3 and just move it out here in front. So that means that du dx is equal to 3 times the cosine of 3x. So easy mistake to make is to forget to put that 3 on there. Okay, now look back up at your box. You need a cosine of 3x. We're supposed to do one more thing first. Let's change it to differentials. So the differential of u would be equal to 3 times the cosine of 3x, and then times the differential of x. So exactly what we did in the previous video. All right, now I need a cosine of 3x dx, and I've got that, but I've got a 3 in front of it. So again, I'll take this 3 and I'll move it to the denominator on this side, which gets me to 1/3 du is equal to the cosine of 3x dx. Now, at this point, I needed a cosine 3x dx, and I've got that, so I'll put a little box around that. And what's in these two boxes agrees. So I can trade this out for 1/3 du. So that's my U-substitution. Again, just to isolate that, I'll stick this in its own little box over here. So there is the U-substitution. Now what that does to the problem is this. U is equal to the sine of 3x, so this entire thing just turns into a u, and I wind up with this. The integral of u squared times 1/3 du. So replace this with what it's equal to, which is equal to this. Now notice what happened in this problem. You started with a trig problem, and in the process of U-substitution, it turned into a non-trig problem that you can just use the power rule on. So that happens sometimes. So sometimes it'll stay a trig problem, sometimes it turns into a power rule problem. Now again, take the constant, move it out in front, which gets you to 1/3 the integral of u squared du. Now find the antiderivative of that using the power rule. So that's going to be u cubed divided by 3 plus c. Now go ahead and multiply the two denominators together, and that will give you 1/9 of u cubed plus c. And the last step is to change u back into what it's equal to. Well, u is equal to, if you look up here, u is the sine of 3x. So the final answer will be 1/9 of the sine of 3x, the entire thing cubed plus c. and I'll stick that in the box. So there is the answer to this problem. So just be aware, on the previous problem, let's go back to that real quick. On the previous problem, we let u be equal to the argument of the trig function. On this problem, you let u be equal to the entire trig function itself. So it just depends on whatever it takes to get rid of this other thing. In this case, to get rid of the cosine, you had to let u be equal to sine. So you just have to play with it to figure out which one. And then also another easy mistake to make, don't forget when you take the derivative of this, it's the chain rule. You have to take the derivative of what's on the inside, which gets you to that little thing right there. So easy thing to forget. I'll put a little asterisk by that. Okay, let's take a look at the next example. Okay, and again, the question here is which one do you pick for u? So you can let either u be the secant or u be the tangent. Now, look back at your list. If you look at the derivative of the secant is the secant tangent. The derivative of the tangent is the secant squared. So let's go way back up and take a look at the definitions. So the derivative of the tangent is the secant squared, so that one's going to work. But the derivative of the secant is the secant tangent, that will not work. So if you let u be equal to the tangent of x, you can get rid of the secant squared. So that's how you'll know which one to pick. So with that in mind, let's take a look at one of these. What I'll do is I'm going to rewrite it now. So my choice of u is going to be the tangent. So I'll put that on the left and make this be the integral of. Now I'll also write it like this, as the tangent of x, the entire thing cubed. And that is going to be my choice of u. Now the reason I picked that is because take this secant squared, like we've always done, and move everything else to the right. So this will be the secant squared of x dx. And I'll put a little box around this. So once you make your choice of u, put everything else in the box. Now just follow the same steps. Find the derivative of u. So u is equal to the tangent of x. Therefore, the derivative of u with respect to x, the derivative of the tangent of x, and let's go back to our definitions way up here, the derivative of the tangent of x is the secant squared of x. So that's going to get me to the secant squared of x. Now since this is a simple x, you don't have to use the chain rule here. That means that the differential of u would be equal to the secant squared of x dx. Now again, I needed a secant squared of x dx, and I've got a secant squared of x dx. So since those two match up, I can trade them out for that right there. So there's my U-substitution. So again, we'll stick this in a little box to isolate it. So here is the work to get the U-substitution. So there is the U-substitution. So now rewrite the problem. So what I've got is the integral of, now this will turn into u cubed du. So the integral of the secant squared, you can trade it out for that. So again, this is a case of a problem that started out as a trig problem. When you do the U-substitution, it actually turns into a non-trig problem. So find the antiderivative of that. Well, the antiderivative of u cubed would be u to the fourth divided by 4 plus c. And your last step is just replace u with what it's equal to. So this will be like having 1/4, and in place of u, replace it with the tangent of x, the entire thing to the 4th power, plus c, and you are finished. So it looks like that. So again, it's a case of letting u be equal to the trig entire trig function itself. And again, which one do you pick? Pick the trig function so that its derivative gets rid of the other thing. Okay, one last problem. And suppose you had this one. I want to show this one just because occasionally you'll get one that it doesn't make any difference which one you pick. The derivative of the sine will give you the cosine or the derivative of the cosine will give you the sine. So you can, in this case, you can pick either one and solve it and you'll get the same answer. So let's just do this one real quick. What I'm going to pick here for u, I will let u be equal to the entire thing here. Now again, why do I pick the entire trig function? If I let it just be equal to 2x, the derivative of 2x will not get rid of the cosine. But the derivative of the sine will get rid of the cosine, so that's going to be my choice. Now in that case, I'll put a box around. This is the part that I'm going to try to get rid of right here. So once I make my selection of u, off I go. And follow the same step you've done. Let u be equal to the sine of 2x. Then find the derivative. The derivative of u with respect to x would be equal to, the derivative of the sine is the cosine, but remember this is a composite function again. So rewrite the inner part, then times, and I think I'll do it in blue again, the derivative of what's on the inside, which would be a 2. So if it's anything other than a simple x, you have to use the chain rule. Now on this next problem, I'm going to go ahead and move this 2 out in front here. So this will give me the derivative of u with respect to x would be equal to 2 times the cosine of 2x. Now that means the differential of u would be equal to 2 times the cosine of 2x dx. When I look back up at your box, you're trying to get rid of a cosine of 2x dx, and you've got a cosine of 2x dx right here. But you don't need this 2, so move it to the other side. So divide both sides by 2, and you'd have 1/2 du would be equal to the cosine of 2x dx. Well, now I'll go ahead and put a little box around this thing. So this now agrees with this up here. So since those two are equal, I can trade them out for this right here. So again, I'll stick this in a little box just to isolate it. So here is my U-Substitution. Okay, so that part right there is the U-Substitution. Now when I do that, here's what I wind up with. This will become the integral, and I traded that entire thing out for a u. Then the cosine of 2x dx is equal to 1/2 du. So this will become 1/2 du. So again, it turns from a trig problem into a non-trig problem in this case. Well, again, I'll take the 1/2 and move it out in front. So that gets me to 1/2 the integral of u du. So some of these will actually turn out to be pretty easy integrals. So that will give me 1/2 of, and this will find the antiderivative of u, which would be u squared divided by 2 plus c. We'll put the denominators together, and that gives me 1/4 of u squared plus c. And my last step is to replace u with what it's equal to. Well, u is equal to the sine of 2x, so the final answer would be 1/4 of the sine of 2x, and the whole thing will be squared plus c. And it looks like this. And there you go, there's some trig examples. But just be aware, on some of the problems, you let u be equal to the entire trig function. Some of the problems, you let u be equal to the argument of the trig functions. Now, which one do you go? It just, whatever it takes to get rid of this other thing. So that's how you'll decide what to pick for you. So, good luck with those.